So in this proof, we're going to dip back into two columns instead of a flow. And two columns, remember the only difference here is instead of just marking a diagram, we have to actually write things out. And we still have the same approach. We're still going to try to prove two triangles are congruent using our theorems. We'll still have to show that three things are congruent, and we should use the diagram to help us out along the way. But we have to list out what we know as we go. And so we see the given information here does not include um, anything as congruent. It doesn't say that something's congruent to something else. It does have some keywords, but even though it doesn't say that two things are congruent, we still write out that it's a very formal process saying, hey, we know this is true. And the reason is given because it was provided. So this one, we see the words perpendicular bisector. We've never seen those two words together, but we should know what each of them means separately. Perpendicular meaning 90-degree angles, and bisector meaning, as we know, to cut in half. So cut in two equal parts. Okay, and so we have that information already that we have a perpendicular bisector. And we're starting off here being told that angle XWY and angle ZWY are right angles. And if you look in your diagram, XWY is here, so it is a right angle. ZWY is right next to it, which makes sense because they are a linear pair, so they have to add to 180. Okay, and so why would we know that those two angles are right angles? That's not something we can just look at and say that it's true. And we're not. The reason is we had that keyword of perpendicular, which guarantees us that there are right angles created. And so because we know we have perpendicular line segments here, we know we have 90-degree angles. And so you can either write the word perpendicular or the symbol, which is like an upside down capital T. Okay, and so this proof is a little guided. It now says that all right angles are congruent to each other, which should make sense because to be congruent means to have the same measurement, and all right angles have the same measure of 90 degrees. So if you know you have multiple right angles, you should also know that those angles are congruent to each other because they're the same size as each other. And so what we're going to recognize is that these two angles that we just showed as right angles are congruent. So angle XWY and angle ZWY are congruent to each other. So that's one piece of given information as congruent. Now we also see that apparently XW and ZW are congruent to each other in statement 4. And so what we're trying to do is figure out, why is that true? We can't just look at a diagram and say that these two things are the same size. Remember, we had that key word in our given information, this word bisector. And the word bisect means to cut into two equal parts. And it says bisector of XZ, meaning big segment XZ was cut into two equal parts, XW and WZ. And so the reason to know that these two segments are congruent is because of that word bisector. And so we would put definition of not angle bisector because these are not angles. So we put segment bisector instead. So it's two pieces of information we know to be congruent. And so now we're out of given information. There must be something that's a guarantee now. And it's always the same ideas. It's either vertical angles or a shared side. And in this case, we see both triangles use the segment WY, meaning that the segment is the same size in each of our triangles. And so to list this, we simply put that YW or WY, whichever way you list it, is congruent in one triangle is congruent to YW in the second triangle because they both use that same segment. And that is our reflexive property. Okay, and now that we have that, we can look at our triangle and we see that we have two pairs of sides marked as congruent and we have a 90-degree angle that's congruent. And that is our setup of side angle side. And so by our side angle side theorem, triangle XYW is congruent to triangle ZYW.